Hello everyone, welcome to section 3.2. We're going to be talking about polynomial functions and their graphs. So we want to be graphing general polynomials, not just quadratics. So here's a question for you. Is this a new day and I'm shooting a new lecture? Or did I just change my shirt and I'm shooting these lectures back to back? Comment what you think below. Okay, so let's write some definition. Let's get some vocab out of the way. So a polynomial function is a function of the form, let's say p of x, which is a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus all the way to, let's say, a sub 2 x squared plus a sub 1 x plus a naught. So this is a general quadratic. Okay, we call this a polynomial of degree n. The word polynomial means many terms. In this case, we have multiple terms. Terms are things that are separated by addition. So we have many terms. Okay, so let's do an example, and let's get some of the lingo. Understand what are these a sub n's, this a sub n minus 1s. So let's say we have a polynomial p of x, which is equal to, let's say, 5x to the 6th plus 3x to the 4th minus 7x cubed plus x squared plus 4x minus 8. Okay, so a few of the kind of the vocabulary is the term that has the largest power, this 5x squared. We call this the leading term. The leading term is 5x to the 6th. Okay. Now, the leading term, again, is the term that has the highest power. So we would call this, since the highest power is a 6, we would call this a degree, and I'll circle the 6, a degree 6 polynomial. And what we call the coefficient on the leading term, we call 5. This is what we call the leading coefficient. The leading coefficient. And now what we call the constant term here, running out of colors, I'll color this on blue. This negative 8, the term that doesn't have a variable on it, we call this the constant term. And now if we're trying to figure out what's a sub n minus 1, so in this case here, a sub 6 would be the coefficient on the x to the 6th term. So what we would have here is that a sub 6 would be 5, in this case, a sub, well, let's think about what the a sub 5 here. I don't even have an x to the 5th term, so the a sub 5 here would actually be 0. We would have the a sub 4 would be 3. We'd have our a sub 3 would be negative 7. We'd have our a sub 2, the coefficient in front of x squared would be 1. We'd have our a sub 1 would be 4, and our a sub 0 would be negative 8. Okay. So let's go ahead and write up a table, and let's try to answer some questions or kind of use the vocabulary on different polynomials. Okay, so example. Okay, so let's have a polynomial p of x. We're going to ask ourselves, what is the degree? What is the leading term? And what is the constant term? Okay, so let's do this for 4x minus 7. Let's do this for 5x to the 5th plus 3x. Let's do it for negative 3x squared plus 3x minus 5. Sorry, I'm standing in front of the board. Let's do one more. How about a 4x to the 5th minus 7x to the 8th plus 9. So maybe take a second and pause the video and see if you can fill out this table. Okay, so let's first talk about the degree for all of these. So for the first one, the highest power is an x. You can think of this as an x to a first. So this would be a first degree polynomial, or this would just be a linear function. The leading term will be 4x. And the constant term here will be the negative sign. For this next one here, the leading term is 5x to the 5th. The highest power is a 5, so this is a degree 5 polynomial, and the leading term is 5x squared. Sorry, 5x to the 5th. And the constant term, notice there is no constant term here, so what we want to think about is there's kind of like a plus 0 here, so our constant term in this situation is 0. For this example here, this is a quadratic. It's a second degree polynomial. The leading term is the negative 3x squared. The leading coefficient would be negative 3. And the constant term would be negative 5. For this last one, be careful, this is not a degree 5 polynomial because the highest power, the largest degree on x, the largest power is an 8. This is actually an 8th degree polynomial. The leading term is a negative 7x squared, because it's the term, x to the 8th, because it's the term that has the largest exponent, and its constant term would be a positive 9. So before we go on to start graphing polynomials, let's talk about some toolkit polynomials, or let's talk about the simplest polynomials. We'll talk about what's called monomials, which means there's just one term. Okay, I'm going to call these the toolkit polynomial functions. Okay. So for the very first one, let's say we have that p of x. Let's say we have p of x. How is just equal to x? So this is a first degree polynomial. In this case here, whatever x value I plug in, I get out the same y value. This will actually be a line with slope 1 and y-intercept 0. The next one is, let's say we have that p of x is equal to x squared. Hopefully you know what this one looks like. This is a parabola. Let's do the next one. I'm actually going to erase a little bit of this and move some things over. So let's move x squared back here. So this is x squared, p of x is equal to x squared. And now let's think about what p of x, which is equal to x cubed, looks like. Hopefully we know this one. It's one of our toolkit functions. So let's think about what this graph looks like if you don't already know. The way I know what x squared looks like is because when I plug in a positive value, I get out a positive value. A positive value squared is positive. And when I plug in a negative value squared is positive. So that's why when I plug in negative values, I'm getting out positive values. For x cubed, When I plug in positive values, I'm going to get an output of positive values. So the graph should look like this. Now it's got a curve like this because 1 cubed is 1. If I plug in 2, 2 cubed is 8. If I plug in 3, 3 cubed is 27, so it's growing pretty quickly. But now if I plug in negative values, a negative value cubed is negative. For example, negative 1 cubed. Negative 1 times negative 1 is positive 1. Positive 1 times an extra negative 1 is a negative. So a negative number cubed is negative. So the graph looks like this. Okay, let's keep going. So let's say, for example, instead of x cubed, let's just go up by a power. What if I have p of x, which is equal to x to the 4th? What is this going to look like? We're just drawing a rough sketch here. Well, this again should look a lot like a parabola. It should look very similar to x squared. It'll just be kind of a little bit more narrow. Why? Because when I plug in a positive value and I multiply it by itself 4 times, I get out a positive value. If I plug in a negative value and I multiply by itself 4 times, I get a positive value. Similarly, if I have p of x, which is equal to x to the 5th, what is this going to look like? Well, I hope you believe this is going to look a lot like x cubed. And if I plug in a positive value and I multiply it by itself 5 times, I'm still going to get a positive value. If I plug in a negative number and I multiply by itself 5 times, it's going to be negative. So if we wanted to keep going up here, if you're trying to think about maybe what x to the 6th would look like, it's going to look still a lot like a parabola. If I take a positive number to an even power, it'll be positive. If I take a negative number to an even power, it'll be positive. Similarly, x to the 7th should still roughly look like this graph. It'll be a little bit more stretched out, but it'll have still this general shape. And if I plug in a positive value and I multiply by itself 7 times, it's positive. If I take a negative value and I multiply it by itself 7 times, it'll be negative. So what we have here is we can kind of generalize this idea. So if I think of this as p of x, which is equal to x to the n, and maybe I put an n here, for what values of n will the graph look like this when n is even? So p of x, which is equal to x to the n, looks a lot like a parabola. This is when n is even. Over here, x to the n will look a lot like a cubic when n is odd. And those are our toolkit polynomials. We'll see you in the next video. Take care.